Today we're looking at finding antiderivatives using substitution. That's what we're looking at today. So I want to go back and we need to remember how to take the derivative of something in the form of this. I want the derivative of f of g of x. So who can help me remember how to find the derivative of f of g of x?
Put a prime. Do you find the derivative of g of x and plug it into f of x?
What you saying, Rob? Good hearing.
You find the derivative of g of x and plug it into f of x?
Nope.
That's what it looks like.
You plug g of x into f of x and you find the derivative.
We can find the derivative as it's sitting right now.
Put a prime after the F and after the G.
What do we do there?
So
Integrate.
Oh wait, you gotta give them the same.
What? You substitute.
Get them on,
You gotta substitute it.
get them on the opposite side.
Danger.
You don't. It's a trick question.
Danny, what is it?
Take the derivative.
You got this.
Tell me out here, Danny.
Turn it upside
I
down.
need to have faith. I need to have faith in you guys.
1 over. Show us an example, and we can tell you.
You do the same thing on both sides.
Write it black.
An example of f of g of x would be. That would be an example of f.
Oh, the
Of
chain
rule. Thank you. Chain rule.
That's so much easier.
That was like my 50th.
You guys have got to know just by looking at that what to do. So what is the chain rule?
You
Derivative
subtract and then
Derivative outside, inside stays the same derivative inside.
And boy, Brady.
Boy.
So derivative of the outside. Inside stays the same. Derivative of the inside.
Derivative of the outside.
Inside stays the same times the derivative of the inside.
Outside, isn't the outside's not 1?
The outside is f. The outside function is f. Inside function is g.
You just put parentheses around it to make it all the same equation, but it's not all the inside.
So that means that the integral of f prime of g of x times g prime of x dx equals
F of X.
f of g of x.
Oh.
Everybody on board with that?
So close. So wait, we're just not gonna use chain rule, we're just gonna switch it.
Tell me why that works.
Is it integration? Is it backward?
Integration is the reverse of a derivative. So if that's my derivative, then integration gets me back to where I started before I took the derivative.
so this is like the fundamental here.
So if I'm integrating what's on the right, then that puts me back to what's on the left. So that means the integral of f prime of g of x times g prime of x dx is f of g of x. So what we need to notice is, and in order to integrate this thing, what is the only thing being integrated? The outside function. That is the only thing being integrated is the outside function. Okay, but in order to do that, what else must be present here? The derivative of the inside function must be present. So if I've got a function inside of something else, and the derivative of the inside function is present, all I have to do to integrate it is integrate the outside function. Okay, and why is it that we know this happens?
Opposite of the derivative.
Well, I didn't write this right. There we go. Why is it we know this is true?
Opposite of the.
Because it's the reverse of the derivative. Since I know the derivative of this is this, that means that if I integrate the derivative, it gets me back to where I started. Okay? So we're just noticing a pattern. And the pattern is, all I have to do is integrate the outside function. The inside function stays the same as long as the derivative of the inside function is present. Okay? That's the pattern we need to recognize. So, let's see if we can do some examples. See if I can reverse the course and make something positive happen today.
Don't be positive.
That was
I
positive.
made mine day.
Alright, so I will integrate from 0 to 1, 2x times x squared plus 1 to the third power dx. Alright, so in order to do this, what is it I need to do?
Integrate 2x.
There needs to
Make sure the derivative of the inside is present.
And what do I need to identify before I can make sure of that?
The inside and outside.
I need to identify the inside function and the outside function. So what is my inside function and what is my outside function?
2x.
Inside is
Two.
2x.
The inside is not 2x.
The inside is
Outside is
x
2x.
squared plus 1.
The
outside is
inside is x squared plus 1, and the outside is
x squared
6x.
cubed.
the cube. We've got to be able to see that this right here is inside of the cube. So you're looking for something that is inside of something else. So x squared plus 1 is inside the cube. Can you guys see that? Alright, because of that, in order to integrate this, what do I have to make sure of next?
Derivative of the inside.
The derivative of the inside is present. Okay? So what we want to do is we want to say u equals the derivative of the, or u equals the inside. So I'm going to set u equal to the inside.
What's u?
We'll get to u later. You don't really need to worry about it right now. When we get into more complicated problems,
Wait your turn.
when we get into more complicated problems that require substitution, then u will come back in. But right now, we don't really need it. We're just putting it in there, and we'll come back and use it later on down the road. So I need to take the derivative of this, and my derivative is 2x dx. So what do I need to make sure of about that derivative? That it is present, and my derivative is present. There's the 2x, there's the dx. So I have identified the inside function, I've identified the outside function, I've made sure that the derivative of the inside is present. And now what am I ready to do?
Integrate
What?
the
Cube.
outside.
I'm ready to integrate the cube. So if I integrate the cube, it turns into,
Squared.
no,
Is a 4.
the fourth. So it turns into the fourth over 4, and we're going from 0 to 1.
So the 2x just goes away.
It's a good question. What can I do at this point to make sure I did x squared plus 4, or x squared plus 1 to the fourth power over 4? What can I do to make sure I did that correctly? Take the derivative of it, and what should I get? What I started with. So if I take the derivative of this, I'm going to leave the 1/4 of there. And now I want to take the derivative of that, so it's going to be 4 x squared plus 1 to the third times 2x. 1/4 and 4 cancel. Is that what I started with?
Yes.
Yes.
So the outside isn't just the cube, it's the whole thing?
The outside is the cube. But when I integrate the outside, what happens to the inside?
Stays.
It stays the same. So that's why inside the x squared plus 1 stayed there, because the inside stays the same.
So you don't integrate the 2x.
No. The only thing that is integrated is what? The outside function.
Okay.
That's the confusing part. Is I'm hearing some of you say, well, how come I didn't do anything with the 2x? Okay? That's the confusing part. Okay? All you have to do is focus in on, I only integrate the outside function. That's the only thing I integrate.
So x squared plus 1 to the 4th over 4. What is that?
That's f of g of x.
So it's the
Yeah, I integrated the outside function, and the inside function stayed the same. My outside function was the cube. When I integrated it, I got that 4, and I got that 4. The inside part was x squared plus 1. That stayed the same.
So what are we finding when we plug in? I don't get that.
What are we finding when we plug in?
plug in a 2.
Yes, we're gonna plug in the 1 and the 0
Why?
because it's
Is that just how you solve it?
a definite integral. This is the same thing we've been doing, except it requires something else to be able to do it. Okay, this is just more complicated than we've been used to. So this still, what does this still represent?
Area.
The area under the curve or the change in the function above. This still represents that. We're just dealing with a more difficult function to integrate. Okay. All right, let's finish this. Move on to the next one. See if we can pick up some steam. So I'm gonna leave the 1/4 out front. I'm gonna plug in 1. 1 squared is 1 plus 1 is 2. 2 to the 4th, 16. Then I plug in 0. 0 plus 1 is 1. 1/4, 1. So I end up with 15/4. And what does 15/4 represent? What does 15/4 represent? Area on the curve between 0 and 1, or the change in the function above between 0 and 1. Okay, same thing. Let's try another one. I want to integrate from 0 to 2, 4x over the square root of 1 plus 2x squared. So, what am I looking for?
Inside and outside.
Inside and outside. What do you want to call the inside?
1 plus 2x squared.
1 plus 2x squared. So, what do I have to do to it?
Integrate it.
Take the derivative of it. So, that gives me 4x dx. And what do I need to make sure of? It's there. So, it is present. So, that means all I have to integrate is the square root. Now, let's move it up to the top before we do that. So the only thing I have to integrate is that -1/2. But what's always going to be inside it?
1 plus 2x squared.
1 plus 2x squared. So I've got 1 plus 2x squared. My new exponent is 1/2. I need to divide by the 1/2, which is the same thing as doing what? Multiplying by 2. We're going from 0 to 2. What can I do to make sure I did that correctly? Take the derivative. So let's take the derivative. Multiply the 1/2 times the 2. What happens? It goes to 1. What's my new exponent? -1/2. Then I need the derivative of the inside, which is 4x. Is that what I started with? Yes. So that tells me I integrated correctly. Alright, so the 2 is going to stay out here. I plug in the 2. 2 squared is 4 times 2 is 8 plus 1 is 9. Square root of 9 is 3. I plug 0 in, which means this is 1. The square root of 1 is 1. So 2 times 2 gives me 4. What does 4 represent? Area under the curve or change in the function above. So on these problems, what do we do first?
Figure out which is it.
Figure out what's
Identify the inside function, identify the outside function. Then what? Take the derivative of the inside function and
Make sure that
make sure it's there.
What if it's not there?
We're getting ready to do that on the next problem. When it's there, then all I have to do is antiderivative of the outside function. What happens to the inside function? Stays the same. And you can always check by doing what? Taking the derivative of it. You should always get back to where you started. Let's try another one. So I want to integrate from 0 to 1 x times the square root of 1 minus x squared dx. Integrate from 0 to 1 x times the square root of 1 minus x squared dx. So what do I do to get started?
Inside.
Alright, so what's the inside?
1
minus x squared.
1 minus x squared. And the derivative of that is negative 2x dx. Is it there?
No.
No, is part of it there. What's
Yes.
there?
X.
What's not there?
Negative 2.
Negative 2. So, that means I need a negative 2 in there.
You can just add it.
I can just add it,
Because part of it.
but I have to also put something in there that counteracts
Oh, divided by negative?
it. Divide by negative 2. So we're going to put it in here, and then we're going to put something on the outside that counteracts it. Because these two right here have to combine to make what? 1.
What if there's no part of it in there? And
If the variable part should always be there. If the variable part is not there, I can't do it. Or there's another method that we're going to learn, and that's the more complicated. That's where the u's going to come into play.
Not wait for that.
What's
How far away is this complicated stuff?
Because this one's
Tomorrow.
just so easy.
Oh.
Tomorrow.
Well,
Yeah,
it's not
Tomorrow.
gonna say-
You guys don't want to come in tomorrow?
No,
You acted
oh,
like it was.
tomorrow's Saturday.
Yeah. Or like Friday. You act like it was so far down the road.
Yeah.
Yeah,
We're
you
gonna
said
be
we'll
learning
deal
that
with you
way
later.
later.
You're not important, or you isn't important.
Alright, so let's move on.
Harrison, you don't matter.
For today, it doesn't matter today. We need to get by today first. Alright, so now I've identified the inside function, I've taken the derivative, I've made sure that the derivative is present. So now what am I going to do? I'm going to integrate the outside. What is the outside? The half. So the inside is going to stay the same. My new exponent is going to be 3 halves. I divide by 3 halves, it turns into 2/3, and I've still got the negative 1/2 that was out front.
Whoa. Time out. Where'd that come from?
Right here. This. Comes down there.
Is that the beginning?
The only thing that moves down is what's outside of the integral. If it's not outside the integral, it's not going to come down. So this means I've got a negative 1/3 out here, and we want to evaluate this from 0 to 1. So I plug 1 in, what does that give me?
0.
0. And then I plug 0 in, and that's going to give me 1. So we end up with 1/3 is our solution.
So on this one, how do you check it to make sure you did it right?
All right,
Because you added a bunch of stuff.
great question.
I'm trying to understand.
This right here was this. That's where I'm at after I've integrated. So all I have to do is take the derivative of this to make sure it works. So I'm going to have a negative 1/3. I bring this down, which is 3 halves. I have 1 minus x squared. My new exponent is 1/2. The derivative of the inside is negative 2x. So the 3's cancel. The 2's cancel. The negatives cancel. And I'm left with x and 1 minus x squared to the 1/2.
Gotcha.
Which is what we started with.
You are so disadvantaged with that. You are so.
Bye.
Oh.
Any calculator?
Look,
See,
Use a
this is
calculator.
why.
then you don't need to do it.
That's what I was wondering. Wasn't there some kind of integral thing where you could, where you let us use a calculator?
It'll tell you when you're using a calculator and when you're not. So if you're using a calculator, you don't have to worry about this. You just punch it in your calculator, you're done.
What?
So you can use your calculator. You can use your calculator to check your answers while you're not at school and don't have the answers in front of you. All right. So integral from 0 to pi over 6 of sine of 3x squared times cosine of 3x dx. What do you think? What's the outside and what's the inside?
Outside is sine.
Outside is the square. So we need to remember that this right here is the same thing as sine of 3x squared. So my inside is sine of 3x. So what do I need to do to sine of 3x? Take the derivative. What's the derivative of sine of 3x?
Cosine of 3x.
Missing something though.
Negative.
Multiply by 3. Don't forget you got to take the derivative of the inside. So the derivative of sine is cosine, the derivative of 3x is 3. So at this point, what do I want to do? Alright, so we notice that this is here, but I'm missing the 3, so I'm going to add a 3 in here as long as I put a 1/3 out there. And here is the important part. Here's where everybody gets confused. The only thing I'm integrating is
Squared.
the square is the only thing I'm integrating. I only integrate the outside function. Whatever is inside the outside function is going to stay, which is sine of 3x. But when I integrate, the square turns into a 3, and I'm dividing by 3. Since this is outside, it comes down also. So we're looking at 1/9 on the outside, and then I'm plugging in pi over 6 and 0. So if I plug in pi over 6, 3 times pi over 6 is, plug pi over 6 in here, 3 times pi over 6 gives me sine of what?
Pi over 2.
Pi over 2, that thing is cubed, minus sine of 0, that thing is cubed. What's sine of pi over 2? 1, and 1 cubed is 1. What's sine of 0? 0, and 0 cubed is 0, so we end up with 1/9. So let's go back to this point just to verify that we integrated correctly. So if I simplify this right here, we are looking at 1/9 sine of 3x cubed. So when I integrate that, I should end up with that. So we bring the 3 down. 3 times 1/9 gives me 1/3. It's now sine of 3x parentheses squared. I need the derivative of sine, which is cosine. And I need the derivative of 3x, which is 3. So the 1/3 and the 3 cancel. And you will notice that this is exactly what I started with. So that tells you we integrated correctly. One more problem.
It's gonna be an absolute value.
No absolute value.
Yes.
Alright, I want to integrate from negative pi over 8 to pi over 8 cosecant of 2x times cotangent of 2x. You'll see why it's pi over 8 in just a second.
Is there an outside one?
So I need to decide what's my outside and what's my inside.
1 power.
1 power will never be your outside.
Why?
Because it doesn't make sense.
Do we need to change something?
We do not need to change it.
Makes
Outside.
There's only one thing that's inside of something else in this problem.
2x.
It's
2x. 2x is the only thing that's inside. So I'm going to say my inside is 2x, which means my derivative is 2 dx. Is it there?
Oh.
No. So I need to add it, which means I need a 1/2. So here is the most important part. I've made sure my derivative is there. The only thing I'm going to integrate is the outside, which is cosecant cotangent. What do I get when I integrate cosecant cotangent?
Cosecant.
I get negative cosecant. So negative cosecant of 2x, I need to bring the 1/2 down.
Can you just change it from pi over 4?
So now I'm going to have a negative 1/2 out front. I plug in the pi over 8, which makes it cosecant of pi over 4 minus cosecant of negative pi over 4. So now you see why the pi over 8.
Yeah.
Okay, what's cosecant related to?
Sine.
Sine. What's sine of pi over 4?
1 over the square root
1 over the square root of 2, so that means cosecant is
Square two.
square root of 2. And what does this negative do to me? It makes it negative as well. So we end up with a negative 2 square root of 2 over 2, which is just negative square root of 2. Logan?
Did you get the negative 2 squared?
I got the negative from here. This is the square root of 2 plus the square root of 2, which gives me the 2 square root of 2. And again, to make sure we integrate it correctly, I can go back to this point, which is negative 1/2 cosecant of 2x. So the negative 1/2 is going to stay there. Now I need the derivative of cosecant. What's the derivative of cosecant? Cosecant cotangent negative. So negative cosecant cotangent. And I have to take the derivative of the inside, which gives me that. So the two cancel, the negative cancels, leaves me with cosecant 2x, cotangent 2x, which is what I started with, which verifies we integrated correctly. So when we're integrating, dealing with composite functions, what do I do first?
Figure out what your inside
Identify the inside, identify the outside. What's next?
Set the inside equal to u.
Set the inside equal to u and
Take
take the derivative.
Make
Make sure it's there. If it's not there,
Then you add it and make something.
put it in there, put it outside to counteract it. Then the most important part, Alex, is when I integrate, I only integrate the outside function. That's the only thing that is integrated. The inside function must stay the same. The only thing that comes down is what? What is on the outside. Then I plug in and finish it up.